The monkey dance.
One job. No ifs, ands, or
Oh,
buts.
oh, there's a chat.
No ifs, ands, or ends, or
Oh,
buts
no problem,
on the
Ellen.
monkey dance.
Come on.
Okay, so anyway,
No, no.
Hey, the man's telling you.
The man, he's not the man. No, he's not the
He's been the
man.
man this entire time.
today, this is just to kind of refresh you on the things we've done this year. If your goal is to actually do well on the AP test, okay, Connor. If your goal is to actually do well on the AP test, because I'm not going to assume that that's all of your goal. I know at the beginning of the year, everybody always asks me about the passing rate for the calc test. And it's usually been about like 35%, which sounds horrible, you know. Of the people who try to pass it, I would say the passing rate is probably close to like 80–90%. So by now, you guys absolutely know some people that just took it to take it, had no plans on passing it, didn't even try to study for it. You know, I guarantee you know somebody like that. And I'm guaranteed there's people in this room that are going to be that person. And I'm not judging you for it. I'm just prepping you if you want to be prepped. So if your goal is to do well, this isn't going to help you that much. What this is just, I'm going to cover some topics. And if you realize that you don't remember any of it, then that means you should probably review it. The AP Classroom is probably your best bet for quick review. Khan Academy won't be that quick. It's all on Khan Academy if you want to watch their videos again. It definitely is not going to be quicker though. And I know that's probably your goal if you're trying to get ready. So I would say AP Classroom is your best bet. It's broken down by units. What I did was I wrote down what information we covered in the units. And, you know, if we're talking about a unit and you don't remember very much at all, then I would probably brush up on that. If this is your only AP test, I would probably start 3 days before the AP test and then cover like 2–3 units a day. And then that way, I would say it'd be a maximum of a couple hours a day, probably. Could be wrong. But you're probably not doing anything in the summer anyway. I know some of you have jobs. Some of you have jobs. But I'm going to guess that a lot of you are probably going to try this summer to just flat out shut off your brains because this year was tough. And that's totally understandable. That's pretty much exactly what I'm going to do. That's usually what I do every year because teaching calc is tough mentally. So I usually shut off my brain for a good 2–3 months. Okay, so unit one. Unit one is on limits. It's going to be 10 to 12% of the total score of the AP test. And so that's one thing the AP College Board did tell us is what portion of the test will be each unit. I don't know if that's helpful or not, but hey, that's what they did. So regular limits, there are 3 types: visual or graphical, which would be a graph; numerical, which is a table; and then analytical, which would be actually just writing out equations. Analytical is the standard or normal one. I put examples of visual and numerical up there. So, where should we go? Why do we have so many people on Chromebooks? Are you guys studying for other tests? I see.
Get a question right.
Wait, let's go with a random number. Do you really have Khan Academy open? Why do you have Khan Academy open? Or did you put it on like algebra?
No, it's YouTube right now.
Okay.
Of
They have it on YouTube?
course they do.
Wow.
That noise is like pure serotonin.
Just look up the baby noises on you.
Okay, I got number 14. So Kevin, you ready? What's a limit? It's kind of a big question, but probably important for the whole unit. If you had to explain a limit in just a couple of words to somebody, how would you try to describe it? Hey, Connor.
You have a range, but these are the things that are range.
Okay, I know what you're trying to say, but obviously somebody else probably wouldn't get that one. Does anybody remember kind of what we did for limits? Yes.
It's like on a graph almost. It's a value that a function will approach but never actually be.
Okay. There's key words that I haven't heard yet that is important for a limit, if anybody remembers them. What you said was good. You're not actually trying to find where a number is. You're trying to look around where a number is. So if the value of a function from the left and the value of a function from the right are the same, then that would be the limit. So this is known as a two-sided limit, which is a normal limit. But from the left and from the right are the key words for limits. Notation-wise, a minus sign represents from the left, a plus sign represents from the right. Do you remember seeing those? Like 3 minus 3 plus. That's one-sided limits. So they have those as well as two-sided limits. So that picture right there, this is actually a pretty common AP question, is they'll just put that picture up there and they'll say, you know, like, what is true about this graph? And then it will say, the limit as x approaches h. What is the limit as x approaches h? B. Okay, so if you're looking on the left-hand side of h, the height of the graph is b. If you're looking at, oh, I keep forgetting I've got a pen. I'm trying to do all these hand gestures, but I can just draw. So the limit from the left is a height of h. The limit from the right is a height of h. So the two-sided limit, so the limit as x approaches h of f of x would equal b. Now, if you were asked for a one-sided limit, they would write it something like this, like h minus or h plus. That would be from the left, from the right. They would also be b. Another question you might be asked about this picture is, what is f of h? Because function values and limit values, they view differently. So a limit value, you look from the left and from the right. A function value, you look directly above the variable or the value. So f of h would be a. Just bring it back some memories at least. Okay, I didn't know if you guys needed me to do a lot more on this. I can't tell if you're confused or if you just remember it. Let's do the numeric table. What would be the limit as x approaches 1 of f of x? 0. Because I can tell that these values are trending towards 0. These values are trending towards 0. And then kind of directly in between those two is 0. The table one is generally the worst because it's very hard to find an exact answer somewhat. You will get table values on the AP test as well. Sometimes they ask you for one-sided limits. So then you only look from the one side. Like a common one is the absolute value of x. So if this was the absolute value of x, or I guess I'd be absolute value of x minus 1. Oops, too much erase. Absolute value of x minus 1 This would be, no. Absolute value of x minus 1 over x minus 1. Because normally it's absolute value of x over x. So this would be -1, -1, -1, 1, 1, 1. And you might get out of the way. I need the pen behind it. No. There we go. So this might say, what is the limit as x approaches 1 from the left? And in that case, we would only look at the left-hand side, and obviously they're approaching -1 because they're all the same. If this asked us for a two-sided limit, then we would say no limit because the left and the right are different. So those were the kind of things we also did. I figure I'm going to take the longest on limits because this is probably the most you've forgotten because we really haven't used them at all. Analytical limits. Well, that was when you had somewhat of an equation. It can be simple. So you kind of remember when we did limits, there was steps involved. The first thing you always try on a limit, analytical limit, plug the number in. If you can plug the number in and get an answer, well, then you're done. Because limit value and function values are the same on continuous functions. There were other things we had to remember how to do. These are kind of hard to come up with off the top of my head, so I will just fake it. So let's say you factored the top and got that. These would cancel. I'll back up a second. First step would have been to plug 4 in, and then you would have gotten an indeterminate of 0 over 0. The next step that we can do is factor and cancel factors. And then this is a whole, but a whole doesn't matter for limits. And then we plug 4 in and get an answer of 5. Now this 0 over 0, do you guys remember what else we did with that indeterminates on limits? Yeah, L'Hopital, which can be pronounced and written multiple ways. So if you have an indeterminate, you can take the derivative of the top and the derivative of the bottom. Maybe I should remind you of the notation. L'Hopital's is in a different unit, but I'm just going to do it right here. That was a bad M. Pretend you don't see multiple M's. What would that be? X squared minus 3x minus 4. Okay, so you plug 4 in and you get 0 over 0, which is indeterminate. Now, if you guys remember, you're not allowed to write 0 over 0. If you write equals 0 over 0, they'll mark it wrong. Because 0 over 0 is an indeterminate and not allowed. What you can write is you can say the, oops, wrong color, but whatever. You can say the limit as x approaches 4 of the top is 0, which is true. The limit as x approaches 4 of the bottom is 0, which is indeterminate form. That's a long word. And because it's an indeterminate, you can use L'Hopital's rule, which you don't have to write L'Hopital's. I mean, you can just write LH. So L'Hopital's rule applies, and from L'Hopital's rule, I can take the derivative of, nope. I can take the derivative of x squared minus 3x minus 4, which would be 2x minus 3. I can take the derivative of x minus 4, which is 1. And because L'Hopital's rule applies, then the limit as x approaches 4 of 2x minus 3 over x, no, over 1 would be 5. Which was a ton more work to get the same answer. So you only use L'Hopital's if you get an indeterminate and don't know how to figure it out a different way. L'Hopital's is kind of like a fail-safe. Now here's the important part. Let's go, Joe. When do I have to write all this? And when is the only time I have to write all this? I mean, you're right, but I'm thinking in terms of test strategy. There's only one time on the test you would have to write all this. Yeah, for your response. If this is on a multiple choice question and you see this limit and know that L'Hopital's rule works, just take the derivative and do it like in your head or scratch work. That's why I'm really worried about free response. Yeah. I really honestly don't know how it's going to work correct. I think there was a limits thing on the whatever box that popped up. I don't know. They've never given one like this before, so I really don't know how they're going to set it up. I'm assuming that the free response questions will be similar. That's kind of why I said I thought it would be really important for you guys to make sure to do the practice test and look at the answer key for free response, because that'll show you how they want you to write free response. With, you know, handwritten, that's really easy to tell you, but typed, I don't know. Okay. Continuity, discontinuity. Let's generate a number and we get number 11. I don't know who 11 is. What do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ready? If I'm looking at this picture on the top with the H, the A, and the B, what can you tell me about continuity or discontinuity?
Which one's the graph?
Yeah, the graph.
It is not continuous over an H.
Okay, it's not continuous at x equals h. This might be a stretch because this is digging deep in the memory. Do you remember what that discontinuity is called?
It's a hole.
It is a hole. Actually, well, the hole is actually at B, but so there are two types of discontinuities. There's a removable and a non-removable. Remember which one? It's okay if you don't, because I'd be like, this is a long time ago. So removable is when a single point is removed. Oh, nice. Internet's going unstable already. A non-removable discontinuity is usually like a gap or a jump. So this would be a removable discontinuity at x equals h. It's probably more common that they ask you to find discontinuities rather than intervals of continuity. But if you were asked to say the intervals of continuity for that graph, then you would say it is continuous. We could probably do it simple and just say continuous x is less than h and continuous x is greater than h. Or you could say it's continuous at everywhere but x equals h. Different ways to phrase it. It's probably going to be a multiple choice more than anything. Okay, last two, and then we'll be done with limits. And then obviously, you guys can go certainly practice them, look them up if you want. I've got two phrases over on the left here, and they mean very different things. I always hate that they phrase them almost exactly the same, but they're phrased correctly. Number 7. Connor.
Yes.
What is limits at infinity? Or what are infinite limits?